Good evening. I'm Lars from Germany, living in Estonia. And yeah, very happy to be here at CraftConf this year. 3 years ago was the last meetup where I spoke, also about approval test. And yeah, in the meantime, I've become one of the maintainers. And so I'm very happy here today to spread the word, tell you more about it, maybe get you excited to also become a user. And that's what I plan to do. Little background, how did I learn about this library and why do I think it's so useful for you to also learn about it? You're software developers or testers, I assume you know about code katas, little exercises where you practice doing TDD, refactoring, again, productivity with your IDE and stuff like that. I do a lot of that in my free time. And especially for refactoring exercises, I think it's very important that you write tests in the beginning so that you know you're refactoring, you're only changing the structure of the code, but not the behavior. And yeah, I learned, I think it was Emily Page, who I learned from that, hey, there's a library which helps you very easily to get this code under test. And then you can start with your refactoring exercise. And I not only do coding katas for myself, I also organized coding dojos at work where I show that to my colleagues. And over time, I noticed a pattern that I teach people about approval tests when we do our katas. They learn about the library, and at some point they realize, hey, here's my production code. I want to write a test for it. I have not written a test before, so we have the code as is. It's untested, potential legacy code. And hey, approval test is the right solution. And yeah, this makes me very happy to see that what I practice with people actually finds its way into production. And this is sort of my value sale, that this is a very good library to use. I think it's one of the essential tools in my testing tool belt. There's, as a Java developer, JUnit, Mockito, approval tests, test containers, availability. So yeah, it's a very important part there. We've done some sightseeing this week. We saw a sign saying, after decades of neglect. And we immediately thought, like, hey, that sounds like a lot of software stories could start. We all know we have existing code, applications, monoliths, or microservices where we didn't spend enough time writing tests for it. But they keep living, they produce value, they're running in production, they will outlive us potentially when we're moving on to new jobs. But that's reality. We have a lot of untested code. I think that's why we're also here today. We're all interested in that topic. How can we become better at testing? So I think approval tests really shines when it comes to covering existing code with tests. Sometimes we don't even know what should it do or what bugs are even in there. And with approval tests, we don't really care too much about it. What we do is we want to characterize the behavior of the system right now. Once we have that done, we can, for example, again, refactor safely. We know it still behaves the same. Or, for example, if we then fix a bug, we can see, OK, now we're more happy with the result than we were before. Approval tests is both a library for Java. There's Swift implementation, Node.js, C++, and so on. It's also some kind of naming paradigm for tests. So I want to somewhat contrast it to normal unit testing. So we all know good practices. When we write tests, we should have a very good name, what we're testing, what is the behavior we care about that we document with this test. We put some structure in our tests. We have arrange, act, and assert, or given, when, then. And last but not least, at the end of a test, we hopefully have an assertion, because otherwise we're not testing much. So in a traditional unit test, you use assert equals. You have an expected value and your actual value. The actual value comes from your system, and the expected value is, again, pre-calculated by yourself or comes from a spec or something. Could look like this. Again, in Java, here's my test name up there. I have very specific behavior I want to test. Who here is familiar with the gilded rose kata? Is that OK? Again, it's a kata, a little exercise. There's a shop scenario where you have items, and every night you sort of run the update quality function to change values in your system that you know is the item expired or what's the quality level of it and so on. And one of the requirements is that aged brie increases in quality the older it gets. So again, cheese gets better over time, so the quality has to increase. And this is what we try to test and verify with this test here. We have our setup. You create your object. You instantiate the class you want to test a method on. We now call that method. That's our action step. And last but not least, we have the assertion. So we said the quality should be 11. Initially, it was 10, and this is what we're testing here. Like when we update the quality for aged brie, it increases from 10 to 11. Very specific unit test. I'd like to argue it's a good test. But how does the approval test look like in comparison? Yeah, again, this is sort of the important line for JUnit test. We have assert equals. But yeah, now to the approval test. I try to structure this similar here. Like we have a name. We don't have a very specific name. Maybe we don't even know the behavior, what we want to test. We just know it does something with aged brie, but no one who built the system initially is here anymore and can tell us. We still have 3 phases because I think it's important for readability, arrange, act, assert in your test. And last but not least, with approval tests, we have a method called verify. And to verify, you just pass the result of the invocation from your system. So if your system returns a string or an item, you pass that to our verify method. And now what happens? In approval test, we store the result of that invocation in a file and say, okay, this is the current state of how it's behaving. When you rerun the test, we will see, okay, we got the same output as we already have saved in the file, so the test is passing. I will do a little demo on that. So the demo gods be with me. Very briefly for the structure that you've seen the test in very large. I mentioned it doesn't have a specific name. Like you can call it approval test if you use approvals library. I have a few other names for approval tests, which I will show you in 2 slides. But I usually think it's not too important to find a very good name because, again, maybe we don't even know what is the behavior we're trying to test. We have the arrange, we have the act, and last but not least, approvals.verify, and where we pass the result to write that into the file. Below here, you can see this is the file that gets created. In Java, we have our class name as part of the file name. We have the method name of our test as part of the file name, and then .approved.txt means this is our approved file where we say this is the current state of the program, which we want to document. And yeah, in comparison to the previous test, this is the important line that changed. So it's not that far from your normal unit test to write an approval test instead. This is the important line you need to know about using approval tests. So yeah, to show that again, if it was maybe not fully clear, I will attempt some live coding. So up here, we have the normal unit test. I will just start executing that once. And OK, type or using a laptop and a microphone at the same time. Not that easy. OK, we see that one is passing. So here, this is the approval test. You see the difference is basically this line. I'll comment that out. I'll show you quickly the file structure. We have only our Java file here, Gilded Rose test. And now I invoke this approval test for the very first time. OK, we see it's failing. Apparently, it also started an application for us. Let's quickly sort of figure out what happened. The first time you run the approval test, you don't have any file yet. You don't know what will my system produce. In that case, you see on the right side, we have the approved file. It's empty. And the received file on the left is, again, what was generated right now with this invocation. So we invoked our actual system, and we got a result. And our test failed because the approved file and the received file, they don't match. You also see that our library in Java, for example, figures out the test failed. I now want to show a diff viewer to the developer to let them know how the 2 files look like. We have plenty of diff viewers supported. There is IntelliJ support. We have Beyond Compare. There is, what's your favorite diff tool? Any? Yeah?
KDiff 3.
I think we have that. We have kaleidoscope, for example. So a lot of things, if we detect you have that installed, we try to invoke them. If it fails, we catch the exception and try the next one. In my case today, I decided let's use the IntelliJ one because with the dark background, it's maybe easy to read. If you can't read it up there, I have some tooling. So up here it says H3, 6, and 11. So this is the toString method of the item class. You see the name, you see the current value for selling, and again the 11 for the quality. What do I do now? I will first close this file. I now see next to my Java test I have the approved file and the received file. And in this case I usually just rename my received file to approved. Refactor, yes, I want to overwrite. And now let's run the test again. Now it's passing, because again, ideally it's not deterministic, this method invocation, so it returns again the same thing, H3, sell-in value of 6, quality of 11. That matches the approved file which we already have. So the test will pass from now on. And again, if I now change the behavior of H3, I remove an if statement somewhere or so, and we don't increase the value anymore, but reduce it, for example, the test will start failing because the received file will differ from the approved file. It's very important that you check in those files to your Git repository. If they are missing, your pipeline will start failing because it doesn't have an approved file. So these become also artifacts, testing artifacts, which have to be under version control. If you don't like it, for example, that they are right next to your Java files, we also have configuration options that you can put them, for example, in the resources folder. But I hope this little demo gave you an idea of how approval tests look like when you use them. We go back here, and I think it's this one. Okay. In case you just figured, hey, whatever he's talking about here, this sounds very familiar, but with a different name. I don't know if you've read Michael Feather's book, Working Effectively with Legacy Code. He calls that characterization test. Bill Wake, if you go and attend his refactoring training, he calls them pin down or pinning tests. There is J.B. Rainsberger, who has a blog article about golden master testing. And last but not least, I think in the JavaScript community with Jest and so on, they call them snapshot tests. But it's basically the same idea. You store in a separate file the current behavior of your application. I call them approval tests because I work on the approval testing library. But yeah, there are different names for the same concept. Questions so far? Are we clear? Okay. In the beginning, I already mentioned there's plenty of implementation. So the approval tests, let's call it project, has many different implementations. We have Java, C++ is very actively developed. Python has a weekly mob programming group enhancing this implementation. There is Swift, which was still recently added and also actively developed. And yeah, for Java, for the last 3 years now, once per week, I'm pair programming with Llewellyn Falco on that. Llewellyn is sort of the inventor of approval tests, both the name and all those libraries. I think the really interesting thing is contributions here to approval tests. They don't just happen like open source. You create an issue, you maybe make a pull request, you solved it yourself. No, to sort of have consistency among all those implementations, Llewellyn prefers contributions by pair programming. So since I'm a big fan of pair programming, we've done that for the last 3 years, and very happy to be here this week and also meet Llewellyn for the first time in person. So yeah, a little shout out. He will speak tomorrow at CraftConf, 2 o'clock in the green tent about writing documentation. And if the mob programming, for example, or with the Python mob, or earlier we also heard about mob programming, sounds interesting to you, in the evening, I think at 7 o'clock, there's also a mob programming session where you can attend and see what this is all about. Okay, so now we've heard about it, why I like it, and saw a little demo. I want to show you a little bit more what there is. It's not a deep dive, but I think it's worth mentioning a few of the methods to give you a rough idea what else you can do there. So approvals verify can accept various objects. We have overloaded methods for string, for maps. We can take object and invoke the toString method on it. You can use result sets if you have code that talks to a database, or if your code is, for example, creating files and you wonder, does the file always look the same? You can also just pass a file object into the verify method, and again, the library takes care that the file each time looks the same. If you have more than one thing to verify, we have verify all. You can pass arrays here or iterables. So again, in Java, most common probably would be a list, array list. Since we're not always just dealing with normal strings, there is JSON approvals where you can pass objects which we then represent as JSON. There is AWT approvals if you, again, build desktop applications for Java and use AWT, for example. Or, as we see in a later use case, you just, for example, create pictures through Java. We can help you approve that. And last but not least, I think super powerful, we all know about parameterized tests. And with approval tests, we have a similar concept called combination approvals with the method named verify all combinations. So if you have multiple input parameters, we will run the test for all different permutations and store the results of all of that into a file. And that is a way how you very easily can achieve super high coverage. And for that, I also quickly will show you a demo. We're here. Okay, so you see I extracted part of our test, the one that creates the string which we want to verify into a separate method. So when I call verify all combination, this accepts a method that returns a string. And then I parameterize that here to test different names with different selin values and different kind of quality. So we create an array with names which we want to test. We have different selin values to use and different qualities. And if I now run this test, the test will fail again. We have no approved file. But you see on the left how many test cases we have. If I scroll to the very bottom, so we got 216 test cases. And again, now we can run the tool, for example, with coverage and figure out, okay, we need a different quality value. One of the requirements in this kata is that no item can have higher quality than 50. So you figure out, okay, maybe I should add 49 and 50 to my input values over here. But yeah, that is a way how to very quickly get a lot of coverage. And you see we have different overloads depending on how many parameters you want to pass in there. But yeah, that's usually the secret weapon when you do a coding exercise where you have to cover everything with tests before you can start refactoring, use combination approvals, and get there very quickly. Okay, I want to show you 3 examples from the real world where people are using approval tests to just give you an idea where people figured out, hey, this is exactly the right tool to write tests. My first example comes from the Keycloak project. Keycloak is identity and authentication open source management software, open source project. And they also have a CLI where you can interact with. Again, basically a binary which you execute from the command line. You can pass different arguments to it. And in their case, it's a lot of text which is returned. Like here on the left, we have their test scenario. They just invoked their CLI and passed the -help flag in there. And then they wrote some test helpers to, again, capture the output to the command line. They redirect that into a string, and that string then they pass to the approvals library. And this is how the approved file looks like. So you see it's a lot of text, there's indentation, and you wouldn't want to write a unit test with assert equals where you assert against this whole test. Just imagine how that test file would look like. You have like 500 lines of test code, and 450 are always just strings where you compare against. Another advantage is if they make any change to these outputs here, again, approval tests will pop up a diff viewer and show them, okay, here, for example, the formatting changed. You now have 2 spaces extra, which is very easy to see if your test tool, if your test suite spawns a diff viewer, which can really highlight, okay, here are 2 extra spaces. It's a lot more difficult if you just see that on IntelliJ on the command line. You saw at the bottom on my screen where it would, like in a terminal, present you the test outcome. So yeah, was, again, I think a very good test case for approval tests if you have a lot of text, for example, to verify. Next, that's directly from my work. I had a few colleagues who had to build with Java on the server an image for our customers that they can then share on social media. So they had a few input parameters. Then they have a lot of AWT code to generate that image. The service then stores that image and gives you a URL where you can look at that image. And the initial testing flow was we start the whole application, we make a web request against it. It stores the image, it returns the URL. We open then that URL in the browser and see, okay, is this image looking like I want it to look like? And then I was like, stop, I have an idea. I know we have some features in approval tests. So in this case, we're testing Java code that looks like this. Like a lot of AWT methods we don't have control over. From this code, we cannot really see what we're building, but the resulting buffered image is an object of a type which we accept in AWT approvals, and the resulting approved file now in our test suite looks like this. And yeah, suddenly it was very quick to test. Are we building the right images? We could very quickly also return, for example, to the product owner. Does this look like you had in mind? How close is this to the Figma images? So yeah, here we have now plenty of these tests. We test basically all combinations of different images which we generate for people to share, different kinds of bets they have placed. And yeah, made me very happy to bring approval tests to my place of work and yeah, tell my colleagues about it. And last but not least, microservices. I guess you've heard about microservices. I haven't built anything else the last 8 years. So we do a lot of integration testing there. You just spin up the whole server, make a web request against it, and see what it returns. And like in the first example, it's usually a lot of text. For example, a JSON response. So here, I don't know how familiar you are with Java and Spring Boot, but yeah, you can just start the whole server. I then have a web test client, which is configured to make requests exactly against localhost where the server is running. So initially, we make 2 requests to store movies in the server. And then I make 1 request to get request to get the list of all movies. And then I do a little bit of converting to get that into a JSON string how I want it. And then I approve it through approvals. And the approved file looks like this. And again, this is just my demo application where I had like 2 movies now stored. But if you think about the API results from your production application, there are usually like way more fields. And again, I will repeat myself, but yeah, you don't want this huge JSON string in your test. If that fails, that doesn't give you much. But if it's nicely formatted and stored like this, it gives you a lot of confidence that the returned API response is looking exactly how you documented it, for example, that it uses camel case or snake case for multi-word strings. And yeah, these 3 use cases is sort of what I brought to you today, what I figured are nice examples on how to use approval tests. If I made you curious enough, here is a QR code to our starter project where you can basically just clone that from GitHub. You have all dependencies set up. There's already a demo test which you can then just run and see, okay, works for me. I have a diff tool. This is the diff tool which was found on my system. This is how the test looks when it fails. To play around, if you're, again, more advanced, you maybe just want to add the dependency to your project. For that, I have a separate QR code. The resources for this talk, I have the slides already up on GitHub, and there's also links to the approval tests website where you can, again, find more links to all the different implementations of all the languages. So I will maybe just pause for a moment here in case you want to take a picture. And then I'm basically nearing the end of my presentation. I will be still here for a while. I heard I get free drinks. So if you want to talk with me, I'm here. And yeah, last but not least, again, some details. My email if you want to reach out, GitHub, my website with my blog, Twitter. And again, I do a little bit of consulting on the side when I'm not working as technical coach for my employer. And yeah, thank you all. Good crowd. Let's have fun.